Okay, so we're going to start talking about parallel line proofs. This is really just getting our feet wet a little bit with proofs and how they work. Okay, so when we do proofs, we are going to have a two-column proof, and on the left, we're going to have statements. These are the things that we're saying. And then on the right, you're going to have the reasons why those statements are true. So with proofs, every statement you make must be supported with evidence, so that's the reason that we know that that's true. Okay, so we're going to do two-column proofs. Like I said, we're going to do relatively short ones to begin with. Okay, some things that you will use as reasons in your proofs. One of the more common ones will be, if the information is given, your reason then is, it was given to us to be true. Okay, well, that's pretty easy. Some other things that you may see, like distributive property, substitution, simplify, those are properties. And you can also use definitions. So definition of congruent angles, maybe definition of a right angle, definition of complementary angles and supplementary angles, which we all know already. So those are just some kind of things you're already familiar with. You just formalize that a little bit. Okay. And then some other things that we know, and maybe a little bit of stuff that should just make sense kind of to you. The linear pair theorem you're familiar with. If two angles form a linear pair, then they are supplementary. And that is just this purple drawing that I have here. If we have two angles form a linear pair, then they have to be supplementary. They have to add up to 180. So we know that already. Vertical angles theorem, those are two angles that are across from each other, are vertical angles. They are always congruent. And it should make sense to you. Right angle congruence theorem just simply says all right angles are congruent. So because they're always 90 degrees. Okay, and then these last two are new, but they should make some sense to you. It says the congruent complements theorem says if two angles are complementary to the same angle, then the two angles are congruent. So I just have here in blue. Let's say we have two angles, 1 and 2, and they add up to 90 degrees. Okay. And then I have 1 and 3 also add up to 90 degrees. In order for this to be true, we know then that this statement here has to be true. Okay. Let's just take a look. Let's just say this was 30 degrees. Well, then that means this is 60. Okay, so that it adds up to 90. Now 1, we know is 30 degrees. Well, that tells us that then 3 would also have to be 60 degrees. So you can see both 2 and 3 are 60 degrees. So hopefully that makes sense, but that's called the congruent complements theorem. And the same thing applies for supplements. So they have the same congruent supplements theorem. That's here in the green. It's just instead of adding to 90, they add up to 180 this time, but everything else follows the exact same way. Okay. Now, these are things right here that we just have talked a lot about in this unit. So corresponding angles theorem, alternate interior angles theorem, alternate exterior angles theorem, and same side interior angles theorem. And then we also know if we're trying to prove two lines are parallel, we can do the converse of those as well. So those here on the right, those are the converse of those. Okay, and then lastly, some properties of congruence that are new to you, but I just want to mention, most of these are pretty straightforward. There's something called the reflexive property, which is simply saying a figure should be congruent to itself. So if we say EF, we know that EF is congruent to itself. We will use this a little bit more in triangle congruence proofs, but that's important. And then the symmetric property of congruence simply says if one thing is congruent to another, if you flip them around, they're also still congruent. So if angle 1 is congruent to angle 2, then 2 is congruent to 1. That's kind of like a no-duh. All right, and then transitive property of congruence. So this one you will use a lot here in this unit, so I'm just going to put kind of a star by it. This says, let's say angle 1 is congruent to angle 2, and 2 is congruent to 3, then that means they're both congruent 1 and 3 are both congruent. So hopefully that makes sense. Let's just kind of say this is 45 degrees is congruent to 2, which is 45 degrees. Well, 2 is 45 degrees, so I'm going to write that here. That means then if they're congruent, 3 would have to be 45 degrees. Well, that's not very good, 45, huh? Okay, so then that means 1 and 3 both are 45, so they are congruent. So that's really all that's saying, but the transitive property you will use quite a bit. Okay, here is our first proof. So it says, given that angle 1 and 7 are congruent. So in your picture, you may want to draw that. 1 and 7 are congruent. Okay. Prove that 4 and 8 are congruent. Okay. We are only given that 1 and 7 are congruent. And the first thing you want to do here, it says a line that I wrote in here. Always start your proofs by filling in the given information. And you can also put the prove part in the last line. So the very first thing that we are told is that 1 and 7, those angles are congruent. So in this first statement, we're going to say angle 1 is congruent to angle 7. And our reason is, as I kind of mentioned, you'll use this one a lot. The very first information that you're given, the reason is we were given that information. So you're just going to write given there. So we already have a third of our proof done. Okay, the thing that you're trying to prove should always go as your last line. We are trying to prove 4 is congruent to 8. So I like to write that down there at the bottom right away. Okay, now we know that 1 is congruent to 7. So that means then that L and M have to be parallel. If they're congruent, L and M are parallel. So I want to write that in there. And how do I know that? Well, I know 1 and 7 are alternate exterior angles, so they'd be parallel by the converse of that. So we're going to write L is parallel to M. And why is that? By the converse of alternate exterior angles. Okay. All right, so now we know that L and M are parallel. We've proved that. So now we can say 4 and 8 are congruent by corresponding angles. And, whoops, wrong utility there. There we go, by corresponding angles. And we've just completed our first proof. This is a relatively short one, but this is really what you're doing, using the logic that we know, the properties that we know, and just kind of taking each one step by step. Okay, let's try another one. We'll do 2 more. Okay, here's another picture. This time we are told that A is parallel to B. So I'm going to just write that. A is parallel to B. 2 and 3 are congruent. Okay. We are trying to prove that angle 1 and angle 3 are congruent. Okay. So the first thing we want to do is write our statements, our given statements. So in the very first line, I'm going to write A is parallel to B. And I'll also write in the second line that angle 2 and angle 3 are congruent. So those are the 2 things that I'm given. And I'm going to write my reasons for both of those will be that they are given. Okay, so just by filling that in, we're already halfway there. Again, it is helpful to write the very last thing that you're doing, which is that we're proving that 1 and 3 are congruent. So somehow we have to get to there. We don't know the reason for that yet, but we got to get there. So A is parallel to B. Okay, 2 is congruent to 3. Well, I want to get to 1 and 3 being congruent. I do know that this angle and this angle have to be congruent because A and B are parallel. 1 and 2 are alternate interior angles. So I can say that 1 is congruent to 2 by alternate interior angles. 1 is congruent to 2 by alternate interior angles. Okay, now here's where we're going to use that one of those new properties we talked about. We know that both 3 and angle 1 are congruent to the same angle. So this is the transitive property. So that's our first venture into the transitive property. So 1 has to be congruent to 3 by the transitive property. And now we've completed our second proof. Okay, again, just write what you know and then take it step by step. They can get pretty tricky sometimes, but hopefully as you get more familiar with each of these, you'll get better and better. Okay, let's try one more. All right. Given that 4 and 7 are supplementary, prove that J is parallel to K. Okay, so the very first thing that we'll do is we want to write angle 4 and angle 7 are supplementary, and we know that the reason is it was given to us. I'm also going to write that J is parallel to K. I don't know the reason for that yet. Okay, so let's see, 4 and 7. Okay, so that's this one and this one. Okay. Well, I can say that 6 and 7 have to be supplementary as well because they are a linear pair. So I'm going to say that 6 and 7 have to be, if I can get that, then I can say, if those two are congruent, then I could say that these two are congruent. They're congruent to the same angle. Okay, so let's write that. 6 and 7 are supplementary. They have to be because they form a linear pair. So that's the linear pair theorem. Okay, now, both these two, 4 and 6, are supplementary to the same angle. So that means that 4 and 6 have to be congruent. Okay, and we said that that was that theorem that we talked about earlier. It's the congruent supplements theorem. Okay, so now we know that 4 and 6 are congruent. So let's see here. Just do 4 and just 6. Now those two are congruent. If those two are congruent, that means J and K have to be parallel, which is what we're trying to prove. So 4 and 6 are congruent. That means J and K are parallel by the converse of alternate interior angles. There, we did it. Okay, so now we've completed another proof. It takes a little practice to just get used to these first times you go through these. It'll be a little tricky, but stick with it. See if something will pop for you and it'll be just fine. Okay, you have a few problems to do on your assignment. Good luck.